In this example here, we would like to solve for x exactly. We're given a logarithmic function, and what you might notice is that these two functions have, or these two logs have different bases. That's a bit of a problem, but we know how to change the base, so we can change this to log base 2 of x cubed over log base 2 of 4. So basically I've taken this logarithm and split it up into a numerator and denominator using that change of base property. I can make this base anything I want it to, and I want it to be 2 so that it matches this 2 here. We know that log base 2 of 4 is equal to 2, so I can rewrite my equation now as 1/2 log base 2 of x cubed plus log base 2 of the square root of x, and that's all equal to 8. Using the power property, I can take this 1/2 out in front, and I can multiply it by this exponent here to make this log base 2 of x to the 3/2 power. And then what you'll notice here is I also changed this square root into x to the 1/2 power. That's going to be helpful in just a second. I can combine using the product property, and now I can make this one log base 2 of x to the 3/2 times x to the 1/2. Using my exponent properties, if I'm multiplying these together, I have to add the exponents. So this all becomes log base 2 of x squared equals 8. And this is kind of how I like to see this, because right now I can convert this into exponential form. So this converts to x squared equals 2 to the 8th. So I could take the square root of both sides, which means that this will equal positive or negative the square root of 2 to the 8th. If I square root the x squared, I get x, and then I get 2 to the 4th or 16, and that's a positive or negative solution. However, it's important that we check these solutions, because upon a second glance here, I'm seeing if I were to take the negative 16 and put it into either of my logs, I'd end up having a log of a negative number, and that's not okay. So really what we need to say here instead is that the answer x is only equal to 16. Why don't you give this problem a shot? Same type of concept, you're going to need to change the base. You decide how you want to do it. Pause the video and resume when you're ready to see the answer. All right, here's the answer. I've got my work kind of laid out for you. Hopefully you can follow some of this here. Note that this is not the only way to solve this problem, but it's how I chose to do it. So you might have gotten something slightly different along the way, but hopefully we all came out to be the same number over here.